So now let's factor some special products.
Okay, if you've been in my class for any period of time at all, you know that I don't like memorization. There's a place for it, yes, in mathematics, but I just don't feel like you have to memorize these two pieces of information in order for you to be good at factoring. You're welcome to write them down if you want, but the methods that I've taught you to factor so far will work even if you don't memorize this. But I will say, if you do have this memorized, it might save you some time. Okay, so whenever you have a perfect square trinomial, first thing you have to do is recognize that it is a perfect square trinomial. So usually what triggers this in my mind is this. If I see that the leading term is a perfect square, and I see that the ending term is also a perfect square, then I ask myself, if I multiplied this together, would I get that middle term? And so, yeah, I do a little bit of this in my head, but for the most part, I do the method that I've taught you already. So anyways, if you want to read through this part, go right ahead. And but do me a favor and just make sure that you understand that whenever you have a plus b and that quantity is squared, that means a plus b times a plus b. I get a lot of people that think that it's okay just to square this and call it good, and that's not correct at all, okay? Because you do have a middle term with this, okay? And over here too. All right, so let's ask ourselves, is this a perfect square? Yeah, it actually is. What about this one? Is this a perfect square? Yes, it is. So at this point, I would test this. And see if what I got was this in the middle whenever I multiplied it out, okay? So if you test this, you get 9x squared, you get plus 6x plus 6x plus 4. And so, yeah, you do get a middle term of 12x. So I know for a fact that is the factored form of that, okay? I always test these, always, always, always. This right here is the testing part. All right, let's try that again. Okay, so is this a perfect square? Yeah. What about this one? Yeah, okay. So what I'm going to test is I'm going to test 9y. Take the square root of the leading term, take the square root of the last term, and because the middle term is a minus, that means we have to have a minus in both places, okay? Now, this is what you want to test right here. We're hoping that this is the factored form of this, which can also, by the way, be written as, okay? But we want to test it first, all right? So let's multiply. Okay, so far so good. And then whenever we combine our like terms, we get, okay, so we did end up with our answer. So I know for a fact that this right here is my factored form. All right, let's take a look at this one. So is this a perfect square? Yes. Is this a perfect square? Yes. Okay, so let's try the factored form that looks like this. Take the square root of this, you get 6x. Take the square root of this, you get 7y. Because this is a plus, I know I need to have a plus in here. And so we want to try out that. Okay, that's what we're testing, which, by the way, can be written as, okay? So now let's go ahead and test it. and then combine your like terms. So this is our answer. By the way, could be written like this or it could be written like this, okay? This is just us testing the work to make sure that it does work. All right, let's look at this one. So, is this a perfect square? Yes. Is this a perfect square? Yes. Okay, so what we're going to test is this. Take the square root of this, take the square root of that, because this right here is a plus, this is going to be a plus. That's what we're testing, but remember that can be written as that. So this would be the factored form if it works. Let's test it though. Combine your like terms. Doesn't work, does it? We did not end up with that middle term, okay? So this one cannot be factored using that method, all right? So here's what we got to do. So let's factor it the way that we were taught how to factor before. So let me erase all this, all right? And let's do 9 times 25. Remember, leading coefficient times the last term, and we get 225, okay? We want factors of 225 that add up to be 50, okay? So again, I always start at 1 just so I know that I've done them all. So 1, 225. I know that 2 won't go in. 3 and 75, those add up to be 78. Nope, not there yet. 4 won't go in, so 225 divided by 5 is 45. There we go, we found it. Okay, so our middle term we're going to rewrite using 5 and 45, all right? So I've got 9x squared plus, and I would put the 45 first just because 9 and 45 go together a little bit better. It doesn't really matter. And now I'm going to factor by grouping. Remember, I just rewrote my middle term using those numbers that we found off to the side over here. Now I'm going to factor out what these two terms have in common. They have a 9 and an x. And what times 9x would give me 9x squared? X. What times 9x would give me 45x? This is a plus, so I'm going to bring down a plus. I'm going to factor out a 5 from those. And I'm left with x plus 5 in there. This matches this, and it has to in order to move on to the next step. So I'm going to factor out my x plus 5s, and I'm left with 9x plus 5. And this is the factored form, okay? So just because your leading coefficient is a perfect square and your ending term or your constant term is a perfect square does not mean that it can be factored into a binomial squared, okay? All right, this is a prime example of that.
All right, so let's take a look at this one. Notice that each piece, each term has a y, okay? And notice also that they're all even numbers. So that means that there's something that we can factor out of each piece of this before we even start to factor, okay? So I ask myself, okay, so they're even, so they definitely can pull a 2 out, but then I need to ask myself, could they pull a 4 or a 6 out? And I can't pull a 6 out of that, but I can pull a 4 out of there, 4 out of there. Yeah, so I can pull out a 4y out of each of these pieces. So that's what I'm going to do first, okay? So factor out a 4y. And what times 4y would give me 36x squared y? And that would be a 9x squared, okay? And then what times 4y would give me a negative or a minus 48xy? And that would be a minus 12x. And then what times 4y would give me a positive 16y? And that's plus 4. Okay, so now let's see if we can factor this. Now remember, this is going to follow us all the way to the end, okay? So we need to make sure that every line we have that, otherwise you'll forget to write it at the end, okay? So now I see that this is a perfect square, and I see that this is a perfect square. But is this term going to be something that whenever I do a binomial squared is going to give me that? Well, let's see. All right, so 4y gets written out front. Take the square root of this and put it there and there. Take the square root of this and put it there and there. And because this is a minus right here, we're going to have minuses in both locations, okay? So now what we want to do is we want to multiply only this piece out to see if we end up with this right here, okay? So off to the side here, I'm ignoring the 4y for now, okay? So I've got 9x squared, and then I've got, oh, I already did that piece, so let's do this piece now. Minus 6x, now we're going to do this piece, minus 6x, and then this times this is plus 4. And whenever we combine those, we do end up with that. So that's good. Okay, so we factored this, all right? So don't forget your 4y out front. And then just to write this in a more simplified form, we would write it like that. There we go. We're done. All right, so one thing I wanted to remind you of with this page is what a conjugate pair is, okay? And notice that whenever you multiply a conjugate pair, your middle term goes away. It's gone, all right? So if we multiply this out, if we distribute this out, we get a squared, and then a times positive b is positive ab, negative b times a is negative ab, and then negative b times positive b is negative b squared. And notice those are opposites of each other, so they go away. Okay, that's why on a conjugate pair, your middle term dies. It goes away, okay, is because you have opposites. All right, so this is just kind of a how-to page, but again, it's one of those memorization pages that, I'm not really a fan of memorizations. So you could ask yourself, does the binomial fit the pattern of a perfect square minus a perfect square? Okay, and if it does, then it's going to factor to be a conjugate pair every single time. And by the way, we call this a difference of squares. All right, so on this one, is this term right here a perfect square? Yes, okay. Square root of this is 8y. 8y times 8y is 64y squared. So yes, that is a perfect square. Now ask yourself, is 1 a perfect square? It's so funny because so many people think, is 1 really a perfect square? Yes, it is, and it's so simplified that your brain doesn't work at that level anymore. So yes, 1 is a perfect square because 1 times 1 is 1, all right? And then you have to ask yourself, is this a minus sign? If it were a plus sign, we'd be dealing with a whole different issue, okay? So it has to be a minus sign right here. All right, so perfect square minus a perfect square means that it factors to be a conjugate pair. So take the square root of this term, put it here and here. Take the square root of this term and put it here and here. And 1 has to be a plus and 1 has to be a minus. It does not matter which one is the plus or which one is the minus, just as long as you have one of each, okay? Now, if you want to check your work, you're totally welcome to do that. And we're just multiplying it back out. So we've got 64y squared, 8y times negative 1 is negative 8y. Positive 1 times 8y gives us a positive 8y, and then a positive 1 times a negative 1 gives us a minus 1. And notice these are opposites, so they go away. So yes, this is our final answer right there. This is one of those places where knowing your perfect squares might be helpful. Okay, so is this right here a perfect square? Yes. Take the square root of that and get 11x. Is this a perfect square? Yes. Take the square root of this, you get 7y. Is this a minus sign? Yes. Okay, that means that it fits our pattern of factoring to be a conjugate pair. So take the square root of this, put it here and here. Take the square root of this, put it here and here. One's a plus, one's a minus. Doesn't matter which one. And there you go. You're done. Right? Your variable doesn't always have to be first, okay? You can still do this problem even if your constant term is first. You will do this the same way. Is this a perfect square? Yes, the square root is 10. Is this a perfect square? Yes, the square root is h. Is this a minus sign? Yes. Okay, so we can do this. So take the square root of this, put it here and here. Take the square root of h squared. We're going to put it here and here. One is a plus, one is a minus. You're done. All right. You also don't have to have any constant terms either. All right, so is this a perfect square? Yeah. X squared times x squared is x to the fourth power. Is this a perfect square? Yes. Y squared times y squared is y to the fourth power. Is this a minus sign? Yes. So this factors to be a conjugate pair. All right, so we've got, let's see here, x squared goes there and there. Y squared goes there and there. One's a plus and one's a minus. Oops, I forgot my y squared. Now, here's the thing though. Check this out. This can't be factored further because there's a plus sign here, but look at this one. Is this a perfect square? Yes. Is this a perfect square? Yes. Is this a minus sign? Yes. Okay, so this can be factored further. Not this one. This cannot be because of the plus sign, but because of the minus sign, this one can be. So again, this turns into our annoying brother or sister that follows us around to the end. But this right here turns into another conjugate pair. Take the square root of that, put it here and here. Take the square root of this, put it here, and one is a plus and one is a minus. Now we've completely factored this. And by the way, whenever I ask you to factor something, I always want you to completely factor it if possible. All right, take a look at this one. Is this a perfect square? No. Is this a perfect square? No. Okay, so let's factor out what they have in common and maybe it'll turn into something that looks a little bit nicer to us. Okay, so what do they have in common? They've got, they're both even, so they've got at least a 2, but what about a 4? Yeah, nope, can't pull a 4 out of that. Okay, so we're going to factor out a 2. They don't both have x's. I can't factor out an x, but they do both have y. So we're going to factor out a 2y out of both of these. So 2y. What times 2y would give me 8x squared y? Well, that would be 4x squared. And what times 2y would give me a minus 18y? And that would be a minus 9. Okay. Is this something that can be factored? Yeah, this is a perfect square, and this is a perfect square, and this is a minus sign. So that means that it can factor to be a conjugate pair. All right, so 2y, and then take the square root of this, put it here and here. Take the square root of this, put it here and here. One's a plus, one's a minus. And now we've fully factored this. All right, so let's take a look at this one. Not a perfect square, not a perfect square, but they do have at least a 6 in common. They don't both have x's, so I can't factor out an x. Let's factor out a 6. What times 6 would give me 6x squared? X squared. What times 6 would give me 96? And that is, why do I keep doing that? 16, sorry. Okay, now, can this be factored? No. Okay, a sum means plus. a sum of squares is considered prime, okay? You wouldn't call this prime though, because we were able to factor out a 6. The thing is, this is the completely factored form because this piece right here is considered prime. But again, I wouldn't call this whole thing prime because I was able to factor out a 6, okay? So this right here is our final answer, okay? I can't do anything else to it because this piece is prime. That's it for factoring special products. Don't hesitate to reach out if you need any help with anything, and have a great day.